Okay, so let's talk about something a little bit new. Let's talk about logarithms. All right, so this is our basic logarithm. It has a couple of things about it. We're going to have the word log, just short for logarithm. It has a small subscript number next to it, which is the base logarithm. It kind of tells us what type of logarithm it is. We're taking the logarithm of this number, and we would get an answer. When we read this, we read it as log base b of a equals c. So one of the big principles of logarithms is that they are the opposite of exponents. So no one really looks at the logarithm and goes, yeah, I understand this, that makes sense to me. So really what we're going to do is we're going to take this and write it as an exponent in order to examine it. And the easiest way to kind of remember this is to circle around in a little spiral. So this statement, log base b of a equals c, is equivalent to b to the c power equals a. So b to the c power equals a. So let's look at just a bunch of examples and kind of talk about them. So if I were to do log base 10 of 100, and we need to figure out what that is, what we're saying is that 10 to what power is equal to 100? 10 to what power is equal to 100? Now sometimes it's easy enough, we can just look at it and go, oh yeah, 10 squared is 100, so the answer is 2. Other times, if it's a little more difficult, we can actually try to break this statement down. So I'm going to rewrite this in terms of 10. So, well, I know it's 10 squared. So we're saying 10 to what power is 10 squared? So my answer is 2. So log base 10 of 100 is 2. Let's do a couple more, just real basics here. Log base 5 of 25 is equal to what? So again, this is saying 5 to what power is 25? So 5 to what power is 25? And we know that would be 5 squared. So again, this is also 2. Now let's see, let's do a couple more. So log base 3 of 27. This would be log 3 to what power is equal to 27. And I know that 3 to the third power is 27. So I know this is 3. Sometimes we can still apply all of our exponent rules that were in there. So a little bit tougher to recognize sometimes is if we're dealing with fractions. So log base 6 of 1/6 is saying that 6 to what power is equal to 1/6. Well, back in unit 6, when we looked at exponent rules, we could actually take this and manipulate it. I know that's 6 to the first and the bottom. So I can move this up top and make it a -1 instead. So 6 to the -1 power is equal to 1/6. So log base 6 of 1/6 is -1. I think we'll do one more basic one here. So log base 4 of 64. So again, this is saying 4 to what power is equal to 64. So to match this, we're going to start breaking it down. Well, I know 64 is 4 cubed. So this is log base 4 of 64 is 3. That's basically our simple operations on logarithms. We're just looking at, we're kind of seeing what they do. Now, when we talked about exponents, we had a big list of exponent rules. There are 7 of them. For logarithms, there's only 3 that we're really going to worry about. So we'll go over kind of each of them. Before we do that, a couple things of note. So there are 2 special kinds of logarithms. So the first is if it's written with no base at all. This is kind of our most generic logarithm, and that's always going to be considered base 10. This will match the log button on your calculator. So if you have a graphing calculator or a scientific calculator that has a log button, that means it is log base 10. If you ever see it written with no base, it is log base 10. The other one, and the one that honestly is more useful in my opinion, is ln, or natural logarithm. I think it's French, actually. logarithm de naturale or something like that. And that is log base e. So just keep in mind, these two are the only ones that we will really see on most calculators. And sometimes these are the only ones we see on online solvers as well. So if you have to do something on a calculator, we need to somehow make them into these. And if you see it, if you see ln, again, that means log base e. If you see a log with no base, that means the base 10 is implied. Okay, so logarithms have three main properties that we're going to take a look at. So our first property, if we are taking the log of any base of two things that are multiplying each other, we can actually split that apart. So the log of these two things multiplying becomes the log of each one separately added together. So we can actually split it apart. Quick example of this would be log base 2 of 5x. If we wanted to, we could split this apart as log base 2 of 5 plus log base 2 of x, and that would be fine. Second property, I guess it would help if we number these. If we have log base of a fraction, or two things dividing each other, that's also going to split up, but it's going to be a minus instead. So that's log of the top minus the log of the bottom. Quick example of this property, if we were doing log base 5 of 8/3, then we could split that as to log base 5 of 8 minus log base 5 of 3. And our final property involves powers. If I have log of a power, or a log of something to a power, we can actually take this power and move it out in front. So that'd become n times log n. So again, as an example, log of x squared, we could rewrite as 2 log of x. So these are all of our real basic logarithm properties. What we're going to do now is we're going to practice doing each of these properties. So we're going to take one and we'll break everything apart using our logarithm properties, and then we'll do another one where we'll put everything back together. So our first would be called expanding a log. When we expand a logarithm, we're trying to break it all apart, kind of like when you're in like 3rd grade and they're teaching you thousands and placeholders, and they tell you to expand the number and you had to write it out as 2 10,000s, 5,000s, 800s, all that. That's kind of what we're going to do with an expanded logarithm. So let's start out with log base 6 of 5x cubed over y. Let's choose kind of some random hodgepodge here. All right, so to expand this, we're going to apply those properties. So as we look at, we're just looking for properties that we can do. So I have something on top divided by something on bottom. So that's our second property. I can split it up as the top minus the bottom. So that'd become log base 6 of 5x cubed, which is the top, minus log base 6 of y, which is the bottom. All right, this one looks pretty good. There's nothing more we can do with it. This we can still break up even more. This is the log of something times something else. So we can split that up using property 1 into 2 different logarithms. So that's the log base 6 of 5 plus the log base 6 of x cubed minus our log base 6 of y that we had from before. All right, this is almost done. We have one more that we can change. This x cubed here, the cubed part by property 3 can come down in front. So as our final answer here, we'll have log base 6 of 5 plus 3 log base 6 of x minus log base 6 of y. This would be fully expanded. We've taken it, we've broken it all apart, we've split everything up. The opposite of this would be simplifying or combining the logarithms. So let's say we had log 9 plus 3 log 2 minus log 3. So something very similar, but to simplify or combine, we're just going to go in the opposite direction. So again, I'm going to deal with here. I have a number out in front, so I can bring that in as a power. So that gives me log base 9 plus. If this comes in as a power, that would give us 2 cubed, which is 8. Now I have 2 logs combined with a plus, so I can multiply the inner terms. So 9 times 8 is 72, giving me log 72 minus log 3. And then finally, if we have the same logs with the same bases and they're subtracting, that means we can divide the interior. So 72 divided by 3 would be 24. So this would combine into a single log as just log 24. So this is just a quick example of what it means to expand out logarithms or to combine them back together. All right, almost done, almost done. So way back when, we would often have to use known values to evaluate logarithms. We don't really have to do this much anymore. We have ways around this now, but it still provides a useful exercise to practice using logarithm properties. So let's say we somehow magically know the log base 4 of 3 is about equal to 0.792, and that log base 4 of 7 is about equal to 1.404. Keep in mind that most logarithms go on forever. They're like pi or the number e. So we're usually going to round them to the third decimal place when we're working with them. So using this information, we can try to evaluate other things. So we could try to figure out what log base 4 of 3/7 is, as an example. Log base 4 of 3/7 isn't something we can easily put into the calculator. And originally when they started doing these exercises, we didn't really have access to a calculator anyway. So what we could do is we could instead try to break this log up into things that make use of this information. So we have the log of something dividing, so we could use our second property. So I could split this up as log base 4 of 3 minus log base 4 of 7. If I split it up this way, I can actually now take, hey, I know what log base 4 of 3 is. It's 0.792. And I know what log base 4 of 7 is. So I can actually just directly substitute values at that point. So that gives me 0.792 minus 1.404. These are just nice, easy numbers now. We can dump them into a calculator, do it by hand, and actually get some answers. So 0.792 minus 1.404 helps if my calculator is actually on. And we get negative 0.612. So again, we took the original that we didn't know how to evaluate and we broke it up into pieces utilizing information we know. All right, how about log base 4 of 21? Again, that's not something we directly know, but we can break it up. I know that 21 is 3 times 7, so I can use our first logarithm property. So that's log base 4 of 3 plus log base 4 of 7. And again, I actually know what each of these are because they are given values. So that's 0.792 plus 1.404. I can plug those in. And we get it's about equal to 2.196. All right, one more, then we'll talk about our last formula, and that'll be it for this little section. So how about log base 4 of 49? Oftentimes, there's more than one way we can actually do this process. So this is a good example of one where there's 2 different ways we can do it. So I'll kind of show both ways. Again, we're trying to write it in terms of the information we know. We know log base 4 of 3. We know log base 4 of 7. So 49, we could say is 7 times 7. And then we could do it exactly like we did this one here. Well, let's try something a little bit different. We could also say that 49 is 7 squared. So I could write it as log base 4 of 7 squared. But our third logarithm property says that we can bring a number out to the front. So on kind of a separate note here, when you're writing logarithms, you have subscripts, you have normal numbers, and you have superscripts. You need to differentiate them in your handwriting. Be clear what is what, otherwise it can get really confusing, especially for me as I try to grade your work. So an exponent can come out in front as 2 log base 4 of 7. And I know what log base 4 of 7 is. That's our 1.404. So log base 4 of 49 ends up being about 2.808. So this is an example of using logarithm properties to break things apart so that we can try to understand what it means. Now, all this is well and good, but what you're really asking is, how can I please do this on my calculator? Because I don't want to do it by hand, and that's going to be our last little thing. So the main difficulty that we have with this is that most logs can't be done on our log graphing tools. So we want a way to actually redo them as any other logarithm. And this is where we come to our final thought, which is the change of base formula. So the change of base formula is a way to change a logarithm from one base to another. So the theory here, if we have a log base b of a, what we can do is we can write that using any other base that we want. And what we're going to do is we're going to take the log of whatever base we want of the normal number divided by that log of the same base that we want of the old base. Looks kind of weird at first, so let's try one out. Let's say we want to figure out what log base 3 of 5 is. So our calculator can usually do normal log base 10, or it can do natural log, log base e. I find over the years that ln comes up more often than normal log, so I tend to think in terms of just doing things with ln. So I'm going to use ln, log base e, to convert this. So I'm going to take the ln of our 5 divided by the ln of 3, and this is now something that we can actually type into our calculator and see what it would come out as. So the ln of 5.0 divided by the ln of 3, oops, wrong button, means that this would be approximately equal to, 1.465. Again, rounding in general to 3 decimal places. So I'll do just one more and then we'll kind of stop it there. Let's say we wanted to do log base 12 of 8. Again, that's not one that we can just evaluate, so we're going to use the change of base. So I'm going to take the ln of the normal number, so ln of 8, over ln of our base, ln of 12. That is now in a format that I can actually evaluate with the calculator. So I put in ln of 8 divided by ln of 12, and I'll get my approximate answer. In this case, about 0.837. All right, and that is it for kind of our introduction to logarithms. Next time, we'll go into how to use them to solve, and then we'll talk about a few applications.